Priscilla B. I work here in Jacksonville, Florida for a company called Kayla H as a bridge engineer in training.
I'm Kayla Hendricks. I also work at H as a bridge engineer in training.
And we're here to talk to you about our UCF pre-stressed concrete structures class project called the Big Beam Project. Our team name is 7 Bridges, and the submission for this is May 1st, 2018.
Here you can see our gross concrete section. We started out with a rectangular section that met the requirements for the section moduli, but then we modified it to kind of resemble an ASHTO beam, but it's a lot smaller than the typical ASHTO beam. It's 18 inches tall and has 12-inch flanges and a 6-inch web. In our end section, you can see we have 4.6-inch diameter strands at an eccentricity of -3.5, and at our midspan we have an eccentricity of 3 inches. We have mild reinforcing steel, 2 number 3 bars in the top and 1 number 3 bar in the bottom. And we also have number 3 bars as our stirrups. There are 2 bars paired together so they can get the pre-stressing strands in between them.
On this side you can see our beam elevations. It's an elevation view of the beam from both the ends. The beam length from bearing to bearing is 20 feet. And the maximum total beam length was 22, but we decided to only add an additional 7 inches. Also, you can see some of the shear reinforcement in here, all number 3 size, grade 60. Here they're spaced at 13 inches, and that was to satisfy the minimum requirement for shear reinforcement. And here you can also see the draped bars coming down from a high, the end eccentricity to the midspan eccentricity. Their tie-down points are at 0.4L.
Here we have our cost estimates. We used 5 KSI concrete, and the total cost for that was around $86. Our 0.6-inch diameter pre-stressing strand was grade 270, and it cost about $35. Our mild reinforcing steel was type A615, grade 60 steel, because that's a common steel used. We used it for the longitudinal and the stirrups, and the cost was about $14 and $45 respectively. The forming was the most costly in the project, and it cost around $143, which brings our total to around $320.
So what did we learn throughout this project? I, for one, learned that the service loading required for the design, a total of 20 kips, as well as the factored loading of 32 kips, wasn't that great of a controlling or demanding influence on our beam design, in that the beam design ended up being very small. The beam had a very small cross section. All of the reinforcement steel that was required for different parts of the design were very, very small as well. So that was interesting to me. Another thing that was tiny about this beam was the cost. Only $320 for this beam to be made due to its materials. I mean, that's not what I expected.
I learned that there's a lot of different pieces to pre-stress design, and with the small window of cracking to the load it needed to carry to when it needed to fail, kind of left not a lot of room in the pre-stressing strand area, eccentricity, or the concrete strength that we used. So after we kind of had our section and our design complete, we tried to maximize the deflection, but there was really not a lot of room for adjustments. One of the major things that we changed later in the design was the top flange. We originally had a 9-inch flange and changed it to a 12-inch flange to push it into the tension-controlled region to use the B factor of 0.9 for pinning.